Welcome, everyone. Imagine for a moment the golden age of aviation, a time when the skies were a vast, open frontier. Before us today is a true legend, the Douglas DC-3, specifically the Flabob Express. In this session, we aren't just looking at an old airplane. We are peeling back the silver metal to understand the skeleton of an engineering masterpiece. As a professional pilot or a dedicated enthusiast, understanding the airframe is like knowing the very soul of the craft. Over the next few minutes, we will journey through the nuts, bolts, and revolutionary designs that allowed this silver bird to conquer the world and redefine air travel forever. Let's dive into the fascinating world of the DC-3 airframe. Look closely at this intricate diagram. The DC-3 was a marvel of its era, featuring a sophisticated all-metal, low-wing configuration. Its fuselage utilizes a semi-monocoque design, which was a massive leap forward. It means the skin itself helps support the aircraft's internal loads. The wings are what we call full cantilever, meaning they are internally braced. This eliminated the messy struts and wires found on older biplanes, which significantly reduced drag and increased speed. As you can see, there are 45 precisely labeled components in this diagram. From the nose cover at the front to the tail wheel at the rear, every single piece was engineered for maximum durability. We see three major sections: a constant chord center wing attached to two tapered outer panels, and multicellular stabilizers that provided pilots with rock-solid control during every flight. To truly master the DC-3, we must break it down into four major assemblies. First, we have the fuselage, a hollow semi-monocoque shell housing the flight deck, the main cabin, and the cargo compartments. Second is the wing, a stress skin masterpiece that tapers beautifully toward the tips. Third is the empennage, the tail section that keeps the plane stable in the air. And fourth are the nacelles, the sturdy housings for those powerful engines, attached directly to the wing's center section. Here is our key idea, the stress skin monocoque design. In most modern objects, the skin is just for aesthetics, but on a DC-3, the metal skin actually carries the weight and tension of flight. This means a dent isn't just a cosmetic blemish. It is a structural concern. It is a living, breathing mechanical exoskeleton. Now let's talk about how this structure actually handles the immense physical forces of flight. Inside the fuselage, we use stations. These are numbered frames, like the famous Station 86 bulkhead, that define the different zones of the cabin and cargo hold. The wings rely on heavy-duty front and rear spars that run continuously through the center section, tied to the fuselage with massive fittings. Interestingly, while the main body is made of tough metal, the control surfaces, specifically the ailerons, elevators, and rudder, are actually metal framed but covered in fabric. This clever design choice reduced weight at the rear of the aircraft, making the plane much easier for the pilot to balance. As we inspect the airframe, remember, every crack or wrinkle in that stress skin tells a story of the aerodynamic loads this legend has endured. If you refer to this detailed parts legend, you will see the incredible complexity of the 45 numbered components we discussed earlier. We can group these parts by region to make them easier to learn. In the fuselage and cabin group, we have everything from the nose cover to the main cabin doors and the Sparta frame fittings. Moving back, the empennage group includes the vertical stabilizer, the rudder, and the tail wheel well. Finally, the wing, nacelle, and engine group houses the flaps, the landing lights, the retracting struts, and the engines themselves. This level of granular detail was revolutionary for its time. Each part, from the exhaust pipe to the tiny cowl flaps, had to be perfectly maintained and synchronized. It is a mechanical symphony where every single numbered component plays a vital role in keeping the aircraft airworthy. As we wrap up our structural tour of the DC-3 airframe, let's review our key takeaways. Remember these fundamental terms. It is an all-metal construction with a low-wing configuration. The fuselage is semi-monocoque, and the wing is a full cantilever design. The most critical point for any pilot to remember is the stress skin load path. The skin is part of the strength. Our stabilizers are multicellular and fixed in a precise alignment to ensure the aircraft remains true and stable in the sky. These features aren't just technical specifications on a page. They are the specific reasons why the Douglas DC-3 became one of the most successful and reliable aircraft in the history of human flight. Thank you for joining me today. Next, we will move on to Deck 05 to explore the flight deck seats and pedals.